Hi there, my name is Joe Drake and I'm the founder of Mechanic Man Manufacturing and the producer of Filter Buddy. And this is part 2 of the 3D printed mold series that I wanted to kind of inform you guys on. It's kind of like a little seminar to as in great detail as I can possibly give you on how to create a system from molds that are 3D printed, that are cleanable, highly reusable, to infinity and beyond, as well as you can see behind me, this is the jig and the injection machine for how I complete the process on making Filter Buddy and making a successful silicone injected mold product that can be done over and over again and at scale, as you can see. So without further ado, let's dive in. So last time we touched up on this video, or this one, whichever one it is, on our 3D printed molds and how these are essentially a 5-piece bottom-fed liquid cavity 3D printed injection molds that we have our Ender 3 print quite a few of these, and that way we can make production at scale of semi-small parts or whatever you really want. So moving forward, if you need more information on these molds, go ahead and check that video out. Everything that is talked about in that video is going to be applied in this little machine behind me. So let's go. So focusing on the jig first itself, this is simply a compression jig. As you can see, this has the capacity for 49 molds. You'll have holes up here, what I'll explain later. And you can do this 4 times a day, producing 196 of these a day, if you make your molds to scale, obviously. So what we have here is this door will come down and clamp on top of these, and they are sucked down with just these simple, I don't know what you call these, reversible clevises that anchor into these and gives it a good squish this way, facilitating our top clamp load. And here we have just a piece of angle iron with a threaded and tapped bar with some jack bolts, and we will push this squarely. We have marks down here to facilitate a square push. And then this all just clamps together. Now this system has to be pretty robust. As you can see, there's a little bit of supports here. There are bolts that go through that tie this top section together. And then I even have these for kind of a trailing load up there to grab. So that way it pulls from over here to here, clamping this very tightly. And without deflection is the main part, especially if you're going to make these out of 2x4s. If you were to do this out of 80/20, I'm sure that you could get away with a little bit less structuring, because the amount of pressure that you put on these isn't a whole lot. It's just a small fraction of what you probably think it is. Now, these boards back here in my holder are spacers. Now, you could design these molds differently. It has the spacer built in, but my goal was to save time printing the molds, as well as these are cheaper than filament and the time to make these spacers. So I put these in here. That way you can remove these after it's done and have kind of space to wiggle these around a little bit and do what you need to do. So for the most part, the frame of the jig is pretty straightforward. It's just a clamp style apparatus. And under here, as you can see, here is our injection point. We will worry about the system later, but as you can see, there's slots and my little support beam. I'm getting ready to add the other 2 rows for production purposes here in the next couple days. So as you can see, here's our holes, and these will line up with these particular valves, which are important. And then of course the top, which goes around our nut. So we have visible access to our moat. And when it fills up, we can visually see that it is full and shut that mold off. And then we just pump all of these full. Now, these are done in rows. So there's 7 rows. And here is your main feed point, and you will do 7 at a time. Standing here from each feed point, here's valves, and I'll get to that later. And that is the gist of the jig. It is supported up, so you can obviously work underneath. It's on casters. So this whole system is a 4x4, 3.5 foot, 4 foot tall assembly. And that is the jig for the most part. So as you can see, the jig itself is a pretty simple design. It is a clamp table. Now you can do this a bunch of different ways. You can actually design this to be adjustable in height and width. If you really put some engineering into it and some 80/20 aluminum extruded building structure, you could make this last forever. You could do it to however big you wanted. You could put it on bigger casters. You can do all kinds of crazy stuff. You put your mold into as a clamping jig to facilitate the clamping forces. Now again, if you watch the other video, you can do this with all thread and other forms. You don't have to make this big of a jig. You can make one that does just one. You can make one that does 2, 6, 10, 49. And this is out of a 4x8 sheet of plywood. So you could double this up into something that makes 98 of them at a whack if you had 98 molds. And of course, cracking them open, removing your material, freshening them up, and putting them back in. So that's pretty much the jig. There's really nothing else much special about it. It's made out of 2x4s, stuff from Home Depot, stuff from Ace Hardware. Again, I'm doing this out of my little small garage, and you don't have to overcomplicate things. If you need something to make a support structure, you don't necessarily need titanium, right? Go see what your options are as far as building material at your local place, and you can make a hell of a jig. And if you have access and the budget for stuff like 80/20 and you're already a really big set company and you're adding one of these ideas as part of your production line, you can use 80/20. You can be fancy however much you want. So, the jig, ladies and gentlemen. So, I guess now we're going to go to the bottom side of the jig where a lot of the important bits of the injection system are housed. Where we're going to start is obviously the tanks. So this is a liquid silicone A and B system of equal parts. We have our A and our B. Now these tanks are pressurized during the injection sequence, and they are pressurized from the top, and we have an air compressor, and it pushes the fluid down through this tube here. And as you can see, this is my Boyi 2-stage silicone injection nozzle, if you will. It comes in A and B. These valves open. It ejects from here and then gets mixed through a static mixer like this one. As you can see, it has this kind of toroidal mixing element to it, and then it comes out the end. So after it mixes, it's gonna harden, and you don't want that stuff in components, obviously, that you're gonna wanna reuse because it's extremely hard to clean. If it gets into valves, it plugs them all up, you gotta pick it out, and it can just be quite the mess. So this system is designed to self-clean. So after we mix our components into here, we're gonna move on to the next section of the jig, which is the injection port. So moving on from our mixed component, this is the injection port here, which is just a 1/2-inch quick connect, which will be the main feed line coming out of our static mixer here. I have a connector that connects this to this port, and as it comes out, it's gonna go through here and tee off and split to the 7 valves that are in this first row. Now these are L valves, and what that allows the fluid to do is, if you turn this, we're going to inject up But if we turn down, obviously the same feed line turns down, and this heads to our reclamation valve, or our reclamation manifold. After all 7 fluid molds are filled, we turn it to that valve where all of our directions here, and it sends itself back to this solvent tank. The solvent tank has mineral spirits in it which clean out liquid silicone that has been mixed very well. So it pumps the dirty stuff into here, and our solvent pump pumps it all the way up here to this manifold, which then gets directed and split to our 7 rows through 2 separate valves. So now that we have curing fluid in here, we plug in our solvent tank side. We're going to purge it with air to push everything to our valve. And then we will turn on our solvent and off our air, turn our solvent pump on, and then our solvent will run through what system has the mixed fluid in, and it will continue to do so, and it will clean itself. You come back in 15 minutes, all of your lines under here are going to be clean, and then you dry it out with compressed air for 5 to 10 minutes, and it's ready for the next injection. Your molds up here will be full, your lines down here will be cleaned and dry and ready for the next injection. The only other thing is to obviously take care of your static mixer. There is another adapter that lets me plug it into the return port of my solvent tank, and I can save these as well. And as you can see, this has been used and it is completely clean. So this is a self-cleaning system. These 2 tanks here are for introduction of new fluid into each tank via a vacuum pump back there. Now it's just a typical automotive pump that I have rigged up into 2 valves that vacuum out each tank, and you suck in new fluid to the tank. Now that it's in there, you continue to pull a vacuum which degasses this even before it's mixed. You don't have any contamination issues as far as bubbling or worrying about if it's going to cure too fast. The only thing you really have to worry about is that when you pump this into there, that you're just maintaining a good eye on these so they don't overflow. So that is a beginning gist of the injection machine and the pump. Now we're going to dive a little bit more into closer look at the valving of how we get all of this to work. So as you can see, our whole jig and silicone injection machine setup is kind of sophisticated. There's a lot going on with this. These tanks are 2.5 gallon a piece. They're 15 liters a piece from Boye. Now you can get smaller tanks that may suit your style, but these systems are still pretty expensive. It's into the thousands for the tanks and just the controller, a couple lines. It has to come all the way from China, and then of course Uncle Sam wants to tax you on tariffs and importation and stuff like that. So it can be quite expensive if you're going to dive into this. I know that there's other ways that you can do silicone injection. Obviously, right, you can mix it up in a little cup, put it in a vacuum thing, pour it into your syringe, you know, hook up your stuff and try to push it mechanically. There's a lot of people doing, you know, can crusher pushes. There's 3D printed rigs I've seen people do with some of the A and B silicone tubes, the big ones. They just don't work very well. Trying to apply mechanical pressure to those and keeping everything straight, especially when most of that stuff's made of plastic, it doesn't work very well. It works about just as well as if you did it by hand. You don't get it to really go any faster. You can easily break the syringe by hand if you're strong enough. That's what was happening with me. So it can be quite cumbersome, and you really, if you're gonna do this in repeated runs, obviously these systems are the way that you want to go. So let's dive into a little bit more about the injection pump system. So I apologize for the dusty mess. I've been doing a little bit of upgrading due to the demand of production needing to increase. So we've increased to 21 molds from 7. We're going to continue production. But anyway, a closer look at our tanks here. Like I said, these are 2.5 gallon tanks. This is our incoming air pressure feed. Now it has a link down here that goes to this other tank. That way that these are balanced. There's not 2 regulators. One regulator feeding the equivalent volume of both of these works best. That way you know that both pressures on top of the fluid pushing down through our valves and obviously out to our injection nozzle. Here we have our suction line, which goes to our fill-up tanks. You just go ahead and pour your gallon or 5-gallon jug straight into this. It goes up into here. Once it's full and all your fluids filled in, you close this valve. You turn your red suction valve on, which again is just wide to both tanks. And then you pull a vacuum on both of these. This really doesn't matter. Maybe 10-15 minutes is enough to evacuate all of the air out of these, so that way you have air-free injections. Now the second part to that of getting air-free injections is the pressure at which you feed. If you feed these, I'm running 28 psi, which is okay. It's as fast or as high a pressure as I want. The reason being, once this fluid starts flowing through the line, it kind of dances and does this little mixing toroidal thing with the head of the bubble, if you will. And depending on if you're pushing it real fast, it will lengthen and those bubbles will get longer. They will spread out and you will see more bubbles and more imperfections in more of the finished pieces as you go. So for our pressure side, that's really about it. There's a pressure relief valve. Always pull off the pressure after you're done. That way there's just not pressure on your valve, not causing any kind of premature leaking or any kind of issues that, believe me, will cause you some problems. So follow that. So you may be wondering how we apply even pressure to this and get this valve to open. So the reason behind a lot of the expense with Boyi is they do have a pneumatic control module. Now I'm sure some of you super techie guys out there could figure out how these work. All it does is applies pressure to either side of a valve, which open and closes the system that you're pushing fluid through. These are really nice because you can do different intervals, you can do set times. On the back there's a switchboard so you can select from different settings if you have different products. I just like to set on my trigger. Now you can set it up to where with every push you get it open. And I find that that works best just to avoid overfilling molds and having leaks. You can do 7 of these in about 8 or 9 minutes. So if you think across the board it takes you an hour to fill this whole board, it's pretty good trade-off just to make sure that you're not wasting fluid and causing a bigger headache than you need with a mess. So again, these come from China. Boyi is about the cheapest one that I've been able to find that actually is suited for what I wanted to do with my application that didn't cost 10 grand or more. It was quite ridiculous. So pressure in, pressure out, yeah. So moving on to our pneumatic side, this comes from our compressor that we have stored in the corner, and it is going to feed both our Boyi controller that is bolted up over there, as well as it is going to feed pressure to our regulator over here to pressurize both sides of the tank. It also feeds me a nice little nozzle for cleaning off dust, debris, and everything else, as well as feeding our main manifold. Now these 7 different lines go to our 7 different rows, all of which have their own valve for air and solvent. Moving on to the solvent side, which as you can see is pumped from our tank. Again, we have 7 leads coming over to our solvent side, which goes to our cleaning line. Now this just unplugs every time. We inject from here to our 7 molds. Once we're done, we pull off our injector. We insert our cleaning line. We purge with air and then run solvent through our system. And that is the majority of the pressurized side. Now, inside of the solvent tank, obviously we have our return line here from our manifold, which this is a static mixer being cleaned with our adapter. So as it pumps fluid back in from our pump, it cleans our static mixer so that we can use it again. Now this line is the factory pump that I use to clean the tank. It goes out to this line, it goes to a bucket, and we service our solvent every several runs. We have a pickup tube that goes down here. There's a crude style filter down there with a collection tank, and it pulls it from the inside through our pump and then goes through the rest of our solvent system. And this is just a cheap Amazon 2 or 3 gallon solvent tank that you can get from Eastwood. If you're doing 1 or 2 molds and you don't have a whole crazy amount to do, you can get away with the small factory one. If you have a 1/4 NPT and you're doing 2 molds, it will do that. If you do 3, I don't think you'll have enough juice. 4, definitely not. So depending on your demand, make sure you have the right pump. Again, all this stuff ordered from Amazon, straight to your door in a couple of days. Highly recommend. So that pretty much wraps it up as far as what the jig is and the injection system. Again, you can source all of these parts from Amazon, Home Depot, Ace Hardware. Maybe a few components were special, I'd really have to think about it, but other than that, I like to use simple ingenuity or the MacGyver method. If you don't have a whole lot of resources and funds to do it the showy, flashy way, who cares? Just make it happen, and it can totally be exactly what you want with a little bit of hard work, some ingenuity, and just kind of plan ahead and think. Quick recap, I always use some mold release agent on your 3D printed molds. A first shot and a second shot, usually throughout production, is usually enough to make these removable very easy. I mean, the parts come out amazing. And it's just good. Like, you can still run it without it if you just can't honestly afford it, but go online to Amazon, get you some of this Appel. It lasts for forever. You don't have to soak it, like literally just a fucking, literally just a psh, and you'll be good to go. So, wanted to say thank you everybody that was watching these little 2 seminars. There is so much more that I could talk about. Again, there is little things here and there and everywhere that make it possible to produce these 3D molds effectively, easily, cost effectively, make them rigid, right? There's a lot of other stuff. I'm going to do a couple more seminars to kind of explain some of the other further details behind 3D printing, the software that you're going to want to run between Fusion 360 or whatever computer-aided drafting software that you want to use to your slicer like Cura. So I really hope that you guys enjoyed this, that you find some knowledge in this stuff. Again, give me a like and a follow, whatever that little thing pops up, to follow along if you found this stuff worthy of your knowledge book. So again, this stuff is totally possible. If you don't believe me, go ahead, take a gander for yourself. This is one of several boxes that I have made for Filter Buddy's release and production. And again, due to foreseeing demand coming up, I'm increasing my mold production to accommodate that. So if you feel like Filter Buddy is something that you want to create, shoot me a message, follow me, get a hold of me somehow. I can give you some guidance on how you can accomplish that. But if you don't believe that you can't semi-industrially make your stuff from your garage at home, I'm telling you, it is totally possible. If you feel like you have an idea and you don't really have the means or anything close to this to facilitate this, again, message me. Maybe we can collaborate together, because whatever can fit into this jig, you can make, and we can put into this mold and produce products, dreams for you. So again, thank you for watching, and I hope you found this knowledgeable And keep up the good work, man. Just keep it up.